Hello everyone, this is Gary Marr of Glendale Community College. This screen capture is from my CIS 150AB students. In the screen capture, I want to cover some topics, concepts, pseudocode covered in Chapter 4 of the e-textbook, and what I started last week in my videos of the lecture and coverage of the textbook and procedural programming from week 4 in Canvas, the week 4 module. This would be the week 5 module. And as I said in an earlier video, many of the topics that we have really span a couple of weeks. We've got a 16-week class. We've got 10 chapters in the e-textbook, so obviously there's not a one-for-one relationship there. So some of the more complicated topics are covered in a couple of weeks, functions being the first one like that. So for this one, I covered the lecture, the PowerPoints, the basic information last week, and we continue this week with some more examples. All of these examples are in the Files section of Canvas. If you look at class examples or class solutions, you'll find it in section 5. They'll be all an order entry application. The first one will have no modules. The second one would have modules. And the third one I'm going to cover will have Python. And again, you're not responsible for Python at all. You're not going to get tested on it. You don't have to turn it in for assignment, but if you want to, you can. Many of you who have learned Python before or have a programming background may want to work with Python now, and that's fine. All right, so this is an order entry application. I've got some business rules on the top as comments. It's got basically the breakdown for how the discount is going to be handled, what's going to be valid in terms of price and quantity, and then what some of the important calculations would be. They haven't mapped out the calculations. They're pretty straightforward. It's got some variables. Now this is using num in the beginning, which doesn't exist, I think, anywhere with a programming language. But what it's supposed to signal for the reader, since this is pseudocode and anything kind of goes, we're preparing this code for someone who's going to program it. This is going to be a number data type for a variable called quantity. It's initialized to be 0. We're also going to have numeric data types for price, discount, extended cost, order after discount. We're going to have a string literal defining a string variable. I could put string in here just to make it more consistent. That's going to be end flag, and we also have some constants that we're going to be using throughout. Constants used in the calculations of the discount. Put a comment in there. Pound signs are Python comments, but they're also going to be comments for our pseudocode. Sometimes I use double slashes for comment characters. That's what the C family of language uses, C, C#, Java, JavaScript. I kind of mix it up to both because I'm not sure what all you guys will be taking in the future, so you might as well see both right now. All right, this is an outside loop that's going to ask for orders, and it's continued to ask for orders until it gets an uppercase Q. The first end flag is set to be lowercase, I saw it someplace, E, so it should pass here as true because an E is not a Q. It comes into the loop. This is some comments. It then has a quantity loop for quantity, a loop for price, basically telling you either it's good or asking you for it to do it again. It does some calculations with a discount. None of these are that complicated, really. It prints out the information, and the bottom asks if you want to continue. If you hit any key, it'll continue. If you hit the letter Q, it'll quit. That's the pre-module version of the program. Now what I did is I created one module called inputs module. There's all the code associated with it. It's a void module. It's not going to return anything. It is going to be no parameters. And so what I could do out here is I could simply say void function or module. And again, remember that module, function, and methods are all kind of the same thing. Void module with no parameters. So when they call this module, it'll have the call statement will just have 2 parentheses also. If there's something inside these parentheses, then it's looking for parameter, which it has to receive, otherwise it'll fail with an error. All right, I got some comments about the business rules. There's my 2 quantity blocks. These blocks before were essentially right where that was there. Now, I guess I'm assuming, and this is the assumption I'm going to make, is that this input routine for extended cost is going to be used by more than one program. So what I did is I modularized it. I pull out that one subtask, the collection of input and its error messages, and stuck that off in its own function or module or method. And I can use that over and over again, either in this program or in other programs or I'm creating the logic for. In this case, just this one, but still, I want you to learn how to do modularization. The next section of the program is essentially the same, just as the processing, all the calculations, printed to the screen. An important part of this one is that you must set price and quantity back to 0, because the way this works is the very last thing it asks me is to give me more input. Do you want an uppercase Q to quit or hit enter? If you hit enter, if you don't erase these values here, in fact, they shouldn't be comment. If you take the comment out, they shouldn't be erased. If you leave those in there, when you come back to the top of the loop, right there, and it goes in input module, which is right there, quantity will equal 0, so it'll ask you for the next quantity of that next product. If you don't reset it to 0, it's going to take whatever quantity it had earlier. If you bought 10 hammers, it's going to see 10 hammers. It's going to continue its merry way because it has a valid value for quantity. So the last thing I must do before returning to the top of the loop is to make sure those key inputs that I'm testing for in my looping are set back to 0. It goes back up to the top. If it's a Q, uppercase Q, it ends. If it's a lowercase q, well, it continues on its merry way. Because with all programming languages, what does this Boolean comparison of a variable to a literal, either string or numeric literal, they have to be the same case if it's going to be a letter. So if I don't key in an uppercase Q down here, it continues on its merry way. I'll let you guys look at this. This is a lot of code to go through, just me whipping back and forth. The code is out on the Canvas Files folder, and there's a link to it inside the Module 5. There's also a link to the Python solution. Now, what happened in Python is I found, and this always happens, there was a couple of errors. The first thing I found was that those comments here, okay, need to be pulled back out. Okay, we need to make sure that everything's reset to 0. Now, what I did is, I just noticed this when I was going through the other example, I put the reset of 0 up on top of the loop. So now that I've done that, I can probably take these out, okay, and the effect is the same. It comes up at the top of the loop. It needs to reset those values back to 0, so it'll go through and ask me for new variables. So I'm going to put right below here that comment also. Oops. Okay. And so what happens there is that this module, when it comes in here, it's going to reset those variables back to 0. Now, I'm using global variables here with this particular solution too. Most of the time, what will happen is if you define a variable out here, and I've already got it labeled, it'll be global, and anything defined within here is going to be local. And what you have to use is balance global and local out with reuse. You don't want to have a lot of global variables and modules you know you're going to reuse, because when you reuse the module, you have to bring the code over, then you have to also remember to bring all of the global information over. And if it changes somewhere along the way, that's going to cause a problem in terms of reusing this code. It's going to have an error in it. So you want to minimize it. The way you minimize it typically is with parameters. Now, I made this a little simpler than one that was good for reuse. I simply said that global variables, quantity and price, would be available for this module to access. So when it says quantity equals 0, or less than equals 0, quantity starts out with the value 0. The first time it comes through, it says, okay, enter the quantity. As long as it's not less than or equal to 0, okay, it'll pass these checks and go on for price. This is very similar to some logic that you're going to find that you would have done in assignment 4 with the coffees, the store name and the store name, price, and I think it was the name of the customer. Same kind of logic pattern. What happens with all logic is that there's typically patterns you'll reuse over and over and over again. You'll use a while loop to block or to test some data validation item, and if it's incorrect, you'll loop back and ask it again. Much more productive than just having an if statement, which only checks it once. If statements check it once, quantity will check it until it's false. So if you always set it false, if they give you an invalid value, it should loop until it gets a good value. And you can see that here I've got a quantity equal to 0. In my testing, I found that I've put a really big value in there. It was causing problems. So I made sure if it was over the maximum quantity of 21, I set this back to 0, so it forced me to get a new value and didn't take my value of 100 and try to continue with it. Because one of the business rules was it was supposed to be if it was over 21, okay, then it was called the maximum order. All right, back up a little bit there. I get too many examples I'm running this week. All right, so look over that. That replaced this section of code, which is indicated by the Python call statement. Python doesn't have anything called call. In Python, when you want to run a void function, you simply just put the function's name, and then any parameters would be inside the parentheses that would be passed up as arguments to the function. It has none, so you have to call it with none. If you put anything in there, okay, at all, then it's going to error because it's not expecting anything. If you add 3 items, then you better make sure the function accepts 3 items. This continues along its merry way. It does the calculation, the discount. What I did is the original version did not have a total cost. It had an extended cost, which I didn't like because it was an extended cost with discount, so it wasn't really terribly accurate. If you tried to do the math with it, you wouldn't be able to figure it out because the discount wasn't really highlighted, or the information that was printed out the end, down here. This is what the first line looked like, which simply just showed you what extended cost was. And then, so what I did is added another line that said total cost with discount was that, and I basically created a new variable to hold that information, and that way gave us more of an itemized look at the end of the program. When you run this, and I'm going to run it inside of Notepad, quantity of 10, price of 10, that means the first one, 10 times 10 is 100, that looks pretty good. Discount for 10, I can't remember what it was, let's see, it was, we move this over here, let's see, it's not going to be easy to find, I guess. Let's see, business rules, looks like it's supposed to be 3%, I think that's right. I haven't actually checked that yet, but I think that's right. And if I want another order, I would hit enter. It would be in my second order. And because I zeroed everything else, it would ask me for a second order. And 5 times 5 is 25, yes. And that one also has a discount too. So it took $3 off that. So let's see, I guess that's almost 10%. And if I want to quit, uppercase Q, and that would end the program. Now what I'm doing here is I'm running this environment in what's called Notepad++. And I've set it up so that when I hit a certain control sequence, it launches Python with this file, this one called orderEntry.py, and it shows it in the command window. I could also use Thony if I wanted to, and if I use Thony, which is a product I've used quite a bit in my examples so far, then I could have the editor and the runtime environment in the same screen. So when I ran it, I'd see my code on top, and I'd see in the shell window the actual program running. All right, now this is a little more heavy. This example is more complicated. So if you have any questions or problems, let me know. Again, you're only responsible for this stuff. And, you know, eyeball to eyeball here, I can, you know, even when I wrote this, I had a couple things I had to change once I actually ran the program. And that's called refactoring, and that's a part of the process. This is one of the reasons that writing logic is so labor intensive, is because as soon as you get in there, invariably you're going to find something you want to fix, either because you don't think it conveys the information correctly, or it looks better, or follows more of a standard, or something. And you're constantly doing that as you're working on this code to make it the, you know, the best, smoothest running program that you can put out there. But with pseudocode, you really can't do much with that. Python, you can't. Pseudocode, it's like you're going to take your best guess as to what you think these statements look like. And what happened to me is in the pseudocode, it was fine. It was pretty close, but when I go over here to the Python, actually tested it, there are some changes that I'd like to make. All right, well, hope that helps. If you have any questions, let me know. You can catch me also during my Zoom office hours pretty much daily except Friday. Bye.